Hello, good afternoon, Data and Tech Stage. How you doing? Woo, yeah, I love to hear the energy. It's so nice to be here at GreenTech Day 2. I'm Henry Gordon-Smith, founder and CEO of Agritecture, as you can read on the opening slide. And we are a global consultancy, but a blog, and we love to share knowledge. And it's a privilege to join for, I think, the 6th year in a row moderating here, and the 3rd time moderating with Blue Radix, a company I'm very excited about. So today we're going to be talking all about something we're all very interested in, which is artificial intelligence, right? You've probably heard of it? Yes, it's everywhere. It's booming around the world. There's a lot of questions about it. How will it work? And especially, how will it work for our greenhouses? So we're going to hear from Blue Radix, some of their partners. We're going to hear about their customers and their growth. And at the end, we're going to take some questions from you. So without further ado, we're going to hear from Rudolf. You want to introduce yourself, and Lóczi as well. Do you want to start with some introductions, and then you can begin?
Yes, thank you. Thank you for introducing us, Henry. Yeah, so my name is Rudolf de Vetten, responsible for product strategy at Blue Radix. And today we will present more about how we integrate not only data from climate computers, but also from other partners. And I'm happy to join the stage with János. János?
Yeah. Good afternoon. My name is János Lóczi. I'm co-founder of Gremon Systems. We are a strategic partner of Blue Radix, and basically I'm going to tell you how we combine with high quality, high frequency data for the autonomous steering.
Yeah, very good. Yeah, and Henry, you introduced yourself already. So let's get started, because at this moment, somewhere there is a greenhouse with a sudden warm night, maybe somewhere in Korea. Grower is asleep and didn't prepare for this very warm night, but luckily he has a system in place that adjusts his climate just in time, adjusts the irrigation, so the watering is correct at the early morning. At the same time, we have a greenhouse with a sudden radiation peak, maybe somewhere in the Netherlands. The grower didn't prepare for it because he's walking around on GreenTech. He's happy because he knows he has a system driven by AI that adjusts his windows right in time, adjusts his 24-hour strategy. Another greenhouse, maybe somewhere in the northern side of Canada. There's humidity rise at sunset. Grower didn't prepare for it. He was very busy, had a birthday yesterday. And still, the greenhouse adapts automatically to it. How this can be done? Because greenhouse dynamics don't wait. And your response should also not wait. That's what we believe. Growers have a lot of capacity, but AI can help nowadays to support growers to get the best out of the greenhouse. And today we want to show you how this can be done. Why is this needed? The need is there every day, and I don't have to tell you, a lot of companies here are working on the same challenges. But energy costs have been rising dramatically, also recent again. Due to all the geopolitical developments, this is an urgent challenge for many companies. At the same time, we see water resources getting scarce. We have many growers that have, many customers that have, during summertime, a very strict water management, and they rely on the daily decisions of growers to do this. Can't we do this in a better way? And these growers, they're getting scarce more and more. Also today I spoke already to a number of companies that really lack the experience, the expertise, while they want to expand. How can we bring this together? We have customers around the world. One of them is Pete Neuveld from 5 Fresh Acres in Canada, and he expressed this very clearly. They want to expand. They have tried to find new growers. They have a really nice modern company, but it just couldn't find the right experience because people are less interested in horticulture, there's competition on the job market, and we have to solve this together. At Blue Radix, we believe technology like AI, when made very practical, very tangible for growers, this can support businesses to scale. And that's also what we see. We are there now for about 5 years. And across the past 5 years, we have seen that we first started with innovator companies that thought this is cool technology. Nowadays, it's embraced around the world. More than 100 greenhouses are running currently fully autonomously running their operations. And these customers, they have about 2,000, even more than 2,000 hectares connected. So this is not something just cool, just technology that's brand new. It's there, it's accepted, and it's running. And we don't do this alone. We work strongly together with partners, and one of our major partners is Gremon. So I'm happy to join the stage with János, because AI can't do it alone. We need data, and we need high quality, valid data. And that's where measurement systems like Gremon comes in. So Gremon delivers the Trucina system. János will tell more about it, with smart sensors, with a lot of logic around it to improve the quality of the data at a very high frequency. And all this data is used not only to support the grower, but to support the AI to make the best value out of that. And that's where Crop Controller, our autonomous system, comes in. So we control heating, ventilation, screens, but also irrigation, based on this data, based on outside conditions, based on weather forecast, and we anticipate and forecast for 3 days ahead. So it's not just a control system that just looks to here and now, but it anticipates on what is coming up. And like many systems, there are many dashboards around. They give you a nice advice, they give you a suggestion. With Blue Radix, we decided to go all the way to autonomous control. It means we directly send this data to the climate computer and directly help growers to get the best out of the climate and irrigation. So day and night, you're assured that you have the best results out of your greenhouse. János.
All right, let me continue the story. Let me tell you a few words about our company. We are a hardware and software developer and manufacturer company. More than 10 years when we started our development, we decided to focus on plant. You can get different type of sensors measuring the environment, but to be able to understand how the plants react under different conditions, circumstances, we have to find a way how to measure plant reaction. Many years ago, already more than 5 years ago, when we met first with the Blue Radix team, Blue Radix has already started with, let's say, the climate automation, but the irrigation model was not ready yet. So this is the project that we were working together on. And we provide hardware components for that, because for the irrigation model this is needed. And the key value is still the data frequency. The 5 seconds data frequency is very important, because if you have data enough, you have a chance to clean. And knowing that maybe one irrigation circle, it takes just 5 minutes. So if you have just 1 or 2 signals in that 5 minutes, then you are not going to be able to detect what's the drainage level during that 5 minutes, what is the water uptake, and so on and so on. So the data frequency is crucial. But next to that, we have also special sensors that we always recommend to install, and one of the key is to monitor the fresh weight production, the biomass production. So why we believe that the fresh weight is a perfect indicator to see the plant reaction? Because of the fact that roughly so fresh weight is going to give you a good indication about the plant water balance. When you are going to have too high transpiration, then you can easily lose fresh weight. And this is a type of stress that theoretically you should avoid. Roughly 90% of the fresh weight is water, and also the biggest part of the irrigated water amount is going to be transpired. But still, the biggest part of the remaining water is going to go to the fruits. So there is a huge and a really high correlation in between the fresh weight and the yield. So that's why we decided to focus on the fresh weight measurement. And we have many results with such example that even under low light conditions, you can produce significantly more fresh weight than in a day when you have light enough. So the question is how you can maximize your daily fresh weight production. In that case, we were able to manage to integrate into our data analysis every type of third-party data. It can be climate computer data or other sensor data. And taking all that data sources, we have a capability to analyze if you have plant stress, losing fresh plant water balance, what's the reason behind? How you can avoid that? And for example, we have the capability to calculate the right set points. Just a little humidity deficit difference is going to cause you significantly more fresh weight production opportunity. And this is something that you should not lose. And because of the fact that even in autonomous control, you as a grower are responsible for your set points. So you have to be sure that the set points that you put into the algorithms, that set points is going to bring you the best result. So this is basically what we do. We help growers with that, with extra service. This is how we call it risk reduction report service. And this is very well appreciated by our customers because somewhere we are in between, let's say, the traditional way and the full autonomous way. Growers can be skeptics about, let's say, the full autonomous solution. But when I tell the grower that if you measure something and based on that measurement you see that, okay, maybe you do not need to open the window that fast. And the autonomous solution can help you to fine-tune that, just to open it according to the necessary level in order to avoid losing too fast humidity level, for example. So basically, this is what we do. We work together with Blue Radix in two different directions. One, if the grower is interested in, let's say, the irrigation module, we have the scale solution for that. But on the other direction, if the grower is also willing to understand which set points is the best, then we can also help with that. So thank you.
Thank you. Yeah, so once you have a good measurement setup with a solid set of slab scales and right data quality, you can think about full autonomy. And that's why we really believe it's this four-step approach. It starts with measuring and analyzing, then set the targets. As a grower, you're still in charge of the targets that you want to achieve. It's not with crop controller that you hand over the keys of your greenhouse and say, well, let's see what happens. You're in charge. But then crop controller, the AI, really helps you to fully autonomously run your climate and irrigation on any moment of the day. And of course, all the effects are measured again. And like János explained, they also evaluate what is the quality of this. So it gives you a lot of certainty. So with crop controller, we focus a lot on technology. We think about set points and climate computers, integration, sensors. But in the end, the plant is in the lead. Sorry. Thanks for your suggestion. So the plant is in the lead. What it means, we calculate the water uptake on 5-minute level. We show what is the plant needing in terms of water every moment of the day. And we do this for 3 days ahead. So we show you what will happen. Of course, we recalculate this every hour. And with that, you get a full insight into the needs of the plant, but also what will be the irrigation strategy. And you can check yourself as a grower what will happen. So it's not a jump of faith, but you can really check it yourself and adjust if needed. Also, the AI helps to find any anomalies in the data. This is a very nice example. We forecast a certain level of water saturation in the slab, but actually the grower started picking So the plant has a different weight on the slab, and the situation in the slab changes. The AI detects this automatically and immediately will detect, like, okay, there was a picking moment, the saturation of the slab will be on a different level. And we can do this because we have all the context around the plant, like the weight, but also when is the water supplied, how much rain was there, and we can detect these anomalies and adjust for it. And this is the type of accuracy which is very hard to match as a human being on a daily basis, but what you can have in your greenhouse now for every day. Oh, go a bit fast. So where does manual and autonomous control, how do that compare on an operational level? There are multiple aspects. Like I said, issues are caught with autonomous control way faster than you can as a human. And with AI, you can take multiple aspects into account. You can take into account your situation in terms of energy usage, your heat usage. You can take into account the state of your plant, but also the outside dynamics that are suddenly changing. And what we see that a lot of companies are looking for with multiple locations is that they have a uniformity in the way they grow their crops and are less depending on decisions in a specific greenhouse by a specific grower, but have a uniform way of decision making in their greenhouses. We know this is impactful to allow an AI to change set points in your climate computer. And that's why we also have a support service that's 7 days a week monitoring your greenhouse. So while you're on GreenTech, there's a support team of Blue Radix checking the quality of the results and intervening, checking with you if there is something that should be changed. And this gives a lot of security in your operation, of course. So what does crop controller contain in practice? We have the climate control I talked about, we have the irrigation control, but we also offer a strategy model for a full crop cycle planning of your strategy. And the last part is, like I said, the support and insight. So we support with people with growing expertise, former growers that support our customers, but also we offer quality reports to help you to understand what was the quality of the crop, what were the results, and how much savings did I have. I'll have an example after this. And that's also what we hear from growers. They say, okay, this really helps me not to change my strategy dramatically, but to improve it and to focus on my strategy and to be sure I reach the goals I want to reach. At the same time, to reduce on energy consumption and running autonomously. This grower has been running autonomously 96% of the time. And this is a typical number we see across our customer base. So on a management level, we also believe autonomous control can help you as a company, because it's not only about supporting the grower, it's also about consistent results and making better decisions. So with this data collection that we do with crop controller, we have a very high quality data set with a lot of context, which allows you to give real-time visibility in the usage of resources, how much energy is used, how much energy is saved, how much water is used, but also the status of the crop. At the same time, because you have a consistent pattern across all your locations, you get a full data trail and KPIs to control if a certain location is performing less than other locations and to compare with for that. On top of that, the reduction of valuable resources, of course, is also in terms of license to operate a very important aspect for many companies. How can you prove that you do the maximum to reduce your CO2 footprint and to increase profitability? So there are a number of aspects from management perspective and operational perspective that really make autonomous control very attractive nowadays. And we show this to growers every crop cycle. What were the results? How did the crop controller do in terms of climate quality, but also in performance of resource reduction? So we believe that the era of AI really has arrived. We have many customers experiencing that every day. And that's also why we upgraded our crop controller recently with a full new user interface, really ready for integrations with partners like Gremon, and also with a very clean overview across your results, not only on grower level, but also on management level across multiple locations. So we really want to invite you to join us in this era of AI and to experience what this can do in your operation. Thank you.
Well, thanks so much to both of you. I'll ask a few questions, and then we can open it up. We've got a full audience here, so please have your questions ready about this. My first one is really about the global expansion, right? I think this is the third time I've moderated a panel with all of you, and it's great to see your growth in these few years. Can you tell us about some of the differences you're seeing in the different markets you're going into? Are they all sort of Dutch high-tech greenhouses? They have to be that? Are there any mid-tech greenhouses you're looking at? What are you learning from the new markets you're entering that are attracted to the AI autonomous growing solution?
Yeah, we see it's really a worldwide development, but you see the triggers are different per country. That's the main thing. So we see in Mexico, water scarcity is a big thing. So there's a lot of interest in the irrigation solution. At the same time, in Canada, it's hard to find experienced growers, but also energy costs are on the rise. So yeah, we are in all major horticulture areas. Australia, we started recently, and there we see similar challenges. It's mainly the way people adopt to it and the amount of training that you have to give. So that's why we also spend a lot of time on translating our services and also the support to make it as local as possible.
Yeah, you mentioned that last year and again this year, right? That step one, that measurement of the data is important. So I imagine not all growers have that organized. How long does that process typically take, or it will range, to get them to have their data cleaned up enough so that the AI can function?
Yeah, so we start actually with without additional sensors. So the climate part, we just can get it running on the climate computer data that's there. And that's a very good way to experience the value of crop controller. For irrigation, we work with companies like Gremon to, if there's no slab scale, to introduce them. And that's a stepwise approach. So depending on the location, it takes a few weeks to install it. But then the data is there. We can, after 3 weeks of data collection, we can start running autonomously. So that's pretty fast.
And so much of this technology, you know, it's new. You're developing it sort of with some of the impressions from the growers. What are the things you're learning from the growers that have influenced sort of the latest versions of Blue Radix that you've learned along the way from them?
Yeah, so we are very thankful for the early growers that started with us and are still there because they had a very young product. We always focused on quality, but we, together with our growers, we have learned what it means to run autonomously. We have expanded a lot on humidity control.
Okay.
Screen control has been improved over the years. So the growers that start now with us have a very mature product that also leverages the experience of all these growers that have gave feedback to us. Still, every grower gets its own model based on its own data. So it's not that we share data across customers, but of course the feedback we get, that is what is implemented. So the feedback is still very limited, actually, what we get on our core product, and that's very good to see, I think. But I don't know, from János, I think you have a similar experience, probably.
Not specifically about how to use, let's say, the autonomous growing, but in general, I feel that growers are getting more and more interested about how to use data and how to integrate into data-driven growing as a concept. But still, they are sometimes a bit skeptic. It depends on also the area. Some area a bit more innovative, and they are more ready to adapt such kind of solutions. And in other cases, we see that there is a conservative, let's say, habit that it's not that easy to break through. So, but anyway, I feel nowadays, due to the fact that there is a huge pressure on how to keep the profitability. So they have to understand how they can save energy, how they can improve the productivity. So without measuring, without, let's say, use that measured data on the best level, they are not going to reach this challenge. I would say they cannot manage that challenge.
Thank you. And I guess a lot of us are experiencing, like, we're getting overwhelmed with the amount of AI companies or what people are doing, and there's such a wide range of them. What I like about what you're doing is it's very specific. You seem very focused on that. But do you have some advice for the audience here, whether they're looking at AI generally or specifically in CEA probably? How do you move past that hype? How do you move past what's real? What are the questions they should ask to find, really valuable AI solutions for whatever problems they're having?
Yeah, I think I talk once in a while about AI, but we try not to talk too much about technology itself, because I think that's not what should be of interest to you as a company. So is your problem really addressed in a way that you still keep control? I think that's important, because you don't want to hand over your keys of your company to an AI. I mean, I did not meet many people, at least, that want that. You want to have your problem solved, and you still want to give direction, to be more in control than before. So to understand where you are as a human in the solution, I think that's very important. And that's how I would assess them.
So focusing on the objective, and again, and how it can empower the human intelligence with the artificial intelligence.
Yeah, and what technology is under the hood can be interesting to have a talk about, but that should not be the differentiator, I think.
Right. Do you have any thoughts on that?
Yeah, actually, I can confirm that. So, due to the fact that we are working with common customers, and let's say the autonomous greenhouse management support is really important. So, if the grower is not sure about a special situation, that someone who can explain the reason behind and someone who can solve it if it's necessary is important. But also in our case, we have, let's say, the analysis, we have the report form, but if we send just a written report form, this is not enough. So growers are really happy to get an opportunity to talk about that, and they can be interactive with us, so we can chat, and the right understanding on that way is much more easy, I would say.
Well, thank goodness that the human and the service side is still important, and we still need it.
Definitely.
I think we can all be fans of that.
Yeah.
Well, please, audience, do you have questions about AI? Oh, we've got an eager one here in the front. Perfect. We love it. Let's wait for the microphone. Thank you.
Thank you. I'm wondering, what kind of AI are you using? Because the only reference to the AI in your presentation is related to kind of optimization of set points. Mm-hmm. But my question is, can your system really learn about what you have been doing this week, the week before, and so on?
Yeah. Yeah, so a nice question. Yeah, like I said, I don't talk so much about the technology behind the scenes.
This is very, very important.
Yeah. So I can tell you a bit about it. So it's a combination. It's a combination of self-learning. So we learn from the data of a specific greenhouse. We don't mix data sets of different greenhouses. We learn from the greenhouse data. We learn the dynamics of the greenhouse. We learn the patterns that a grower used in the past successfully and what was not so successfully. So that's the self-learning. Then we use optimization to improve compared to what was done in the past. And then we also use crop knowledge, crop expertise, which is very powerful. There are things that are not in the data, not well captured in the data, but just that what we know. We know it makes sense to use a radiation temperature ratio. We know there is humidity temperature balances, these kind of things. So we also use more deterministic models. And it's this combination and bringing this together that brings the value. It's not so hard to build a single machine learning model. Throw in a lot of data and it will predict something. It's way harder to find the right model for the right solution. So crop control nowadays consists of about 20 models, all really catered for the specific goal and what they should achieve. But a grower will not experience this. They will experience one product that interacts seamlessly together.
I can suppose that your data structure internal in the system is totally congruent with your statistic treatment of the data.
Yeah, well, we can go into the details at a later moment. But yeah, we think a lot about data structures, how to store the data, and how to make it available for growers again.
Last question.
Yep.
I don't want to worry you. Are you talking about Bayesian statistics?
We can talk about technology at a later moment. Yeah.
Thank you so much for this very informative session. My question is about, again, the AI adoption, if you don't mind. I'm very interested in this new feature you said about the set point prediction, right? My question is, how do we build this human in the loop, right? Do you have a data on how many times the grower overrides the set point prediction? And do you have any explanation or interpretation of the set point prediction, and what are the reconcile mechanisms between the AI and human disagreement?
Yeah, we monitor if our system is running autonomously, so we can see is the grower intervening or not, and not to punish the grower and say, hey, you should not do this, but it's a great learning source because apparently the grower did not agree with us. So our ambition is that he feels confident that he is running 100% of the time. Of course, there are always cases that you as a human know better. So 96% to 97%, which is normal, but I think already a great result, I would say. So the human in the loop is really on the strategy. So there are a number of strategy settings that you can set, and we monitor also how often are these changed. And typically we say we should change settings maximum twice a month instead of 3 times a day. That's quite a difference, what a grower currently is doing. And that's how we monitor, is the balance between human in the loop still okay. We expect the grower to intervene once in a while because his crop is changing, energy prices are changing. There can be a lot of context factors that lead to a change in your strategy, which is fine. But if you do that on a daily basis, we did something wrong in crop controller. So, and on top of that, we have what János also mentioned, this autonomous greenhouse manager, that are people from our team that really check in with the grower every 2 weeks to check, are you happy with the results? Do you understand what we are doing? And also to explain things that a grower has questions about. So it's really this combination of human support while the AI is doing the hard work day and night, creating the best possible set points.
Yes, if I may ask another question, very quick question. I know that most of the predictive model, they can actually operating on the knowns, right? Historical, what has happened. However, there are some exogenous factors, such as like a climate or earthquake, knock on the wood. Like how do you think your AI model going to handle these exogenous, unpredicted, unknown factors?
Yeah. Now, what is unknown stays unknown. We cannot solve that. What we can do is react very quickly as soon as an unknown situation happens, monitor this, warn a grower, or adjust as soon as we can. So our models are keep learning every day. The models are trained again, so it adjusts also according to the situation. But things like earthquake, yeah, that's. But we spend a lot of time on making our systems robust. That's the only way to reach this 97% of autonomy. So also in cases of rare circumstances, we should be able to do some, give a decent reaction at minimum. Yeah. Okay.
Maybe I can add an interesting comment to that, because why the human interaction in between, let's say, the grower and the autonomous greenhouse manager is so important. So, for example, you can produce the same variety even in the next year. But by any reason you decide that you want to increase the density, and that more leaf area is going to create a different microclimate situation. And this is something that can influence, let's say, the set point a lot. So, and if the let's say the communication is working fluently in between those two experts, then you can react in time. Otherwise, you can maybe see the result just later, and that's why yeah, algorithms cannot detect that you have higher density.
Got a few more minutes, Gus. There you go.
Thank you. Hello, everyone, and really appreciate that for taking the stage to educate us more about this. My question is about the accuracy of the models that you're using. Do you kind of have like set a threshold where it will notify you or something if it's below the threshold of the accuracy level, or how are you handle that? Just curious to know.
Yeah, that's a nice question. The interesting thing about what we do is that we predict on a 5-minute level for 3 days ahead, very accurately. So we see also when the greenhouse deviates from our prediction, and yes, we have certain bandwidths, and these bandwidths depend on the type of variable, like temperature has different bandwidth than humidity and radiation, etc. But what we see many companies trying to do with dashboarding is to show some bandwidth where the temperature should be in. But this is very generic because they don't know exactly what will happen. We can use very narrow bandwidth because we have an expectation what will happen in the greenhouse. And even better, we control the greenhouse. So if it's not going according to the plan, apparently something is really off. So we see when windows do not open, but we expected them to be open. There might be a malfunctioning of the windows. We see this with screens. We see that when a humidity sensor is out of bounds, it might be that maintenance is needed. So the level of accuracy we have been increasing dramatically because of this accurate predictions.
A little bit more time. Anybody has questions?
Hello, thank you. Can you hack into any climate computer? And second question, do you really need a climate computer?
Well, the last one is a bit generic question. Can we hack into? Yeah, potentially we could, but we rather partner with companies here on GreenTech to collaborate on the integration. We have now integrations with Prefa and Ridder climate computers, fully integrated. We work with our product teams together to set up how the control should work. And I strongly believe that it's very good to have a hardware system on site that is doing the actual control, the very fast control loop, while we are the intelligence layer on top of that hardware. And that's the role that we take, and we work together with several climate computers, and we are also exploring more collaborations nowadays.
So raise your hand if you have a question.
If I understood correctly, you need 3 weeks of data before start controlling on irrigation, right? So how do you see the beginning of the season, the rooting in phase, for example, of tomato, cucumber? How do you have a solution for it, or is it really just up to the grower?
Yeah, we see typically in this stage, irrigation is very infrequent, very manual often. So that at that stage, you cannot do so much autonomously. We will explore that, but the main challenge for the most growers is once the rooting is over and going into the crop cycle, and then 3 weeks of data is enough. We can do with less data, but there's a bit more risk of inaccuracy at that moment.
Thank you.
Probably take one final question. There we go, in the back here.
how do you take into account the crop development? So, especially, of course, the actions that you take now, you need to probably balance their costs with the benefits in the future.
Yeah. Yeah, so this is where we really work together with the grower. So grower sets the crop strategy and also observes the crop, but it really helps to have a system like Trutina of Gremon that also monitors the crop development. So there we really work together to check based on the data, is the strategy correct that the grower sets? But it's, we take crop development into account. We know about the age of the crop, we know about the state of the crop. But it's still up to the grower to make the large decisions. And we also think it's important that the grower is doing this about, I want to grow now more generative or more vegetative. But of course, we detect from the data if the crop is getting out of balance. And that's the moment to check in with the grower. Like, hey, we see this. Should you not have a lower day-night difference, for example? And based on that, we continue the autonomous control again.
Thanks.
Yep.
You can also see that on the data performance. So if the strategy goes to either climate or irrigation into generative steering strategy, then you can use that information to alert, let's say, the grower, take care. And that's why, again, the human interaction is going to help.
Okay, well, big thank you to our audience, our two speakers today, and Blue Radix. Blue Radix, which booth are you at? Remind us. Oh, we got it here.
It's gone 01251.
There we go. Great memories. That's in Hall 1. And yeah, we'll have a round of applause. And there's some booklets for Blue Radix going out, I believe, from the team here. So you can learn more about them and speak to them. So thanks so much.
You're welcome.
Okay.